Good morning and welcome back to the AI Integration Center podcast for another episode. I'm your host, Lieutenant Colonel David Paddock, and today we're joined by Captain Adam Knapp. Last episode, we discussed what AI is and isn't, walked through some definitions, and laid the groundwork for understanding AI. Today, we're going to dive a little deeper and work to understand functionally how AI works, specifically in a large language model. Adam, thanks for joining us today. Let's get started. Tell us a little bit about your background, how you came to be here today.
Certainly. Good morning, sir. So my background is Army engineer. Did my lieutenant time down at Fort Bragg prior to going to CMU, getting my master's there in information systems management, kind of a focus in the AI framework, and then came here to the center into the soldier and sustainment portfolio, transitioning over to the ground maintenance space. So here in the center, I'm the product lead for Centaur. I've kind of focused in the ground maintenance space, transitioning work to both Army Sustainment Command and POGCS. So that's a little bit about myself. Happy to dive in and excited about today's topic.
Yeah, and I think it's a big topic because when we talk about large language models, that's really where most people are going to interface with AI directly for their first time. It's going to be their first orientation to AI. Can you tell me a little bit about how those LLMs come into being and those phases of operation that they use when they're developing?
Yeah, certainly. When we talk about AI, there's a lot to it, but I think when we have these language LLMs, it can kind of feel like a black box where you go and you ask it a question and it just kind of spits out a response. Sometimes they're incredibly useful and accurate, where I'm trying to plan a mission, it will work me through the steps. Other times you might see instances where those LLMs kind of deviate, and you might see something that we'll talk about a little bit later called hallucinations, where that's nowhere close to the type of response that you would think that you could receive.
And it does seem like a black box, right? I don't see what's happening behind it. And over time, we've gained context for understanding how some of these common internet tools work. We understand that Google has rankings and they provide weights to these different websites. But at the end of the day, all it's going to do is tell me what website best fits based off of some sort of algorithm. LLMs have a lot more to it because they're able to generate more than a response. They're able to create at least what appears to be their own creative solutions. Is that what's actually happened?
So under the hood, it's just like your other types of models or algorithms. AI, LLMs, it's just math and patterns built on historic data. So when we talk about these LLMs, really it's taking a look at a bunch of other natural language across the corpuses of text, sometimes all of Wikipedia, sometimes even in instances looking at Facebook or other social media doctrine and learning how people talk. And it's kind of mimicking that in its training process. It's taking these natural language aspects and kind of honing into how an algorithm can almost speak back to you.
So it seems like the data for a lot of this is the words that exist in the universe, millions and billions of pieces of text and documents, and it's absorbing all of that in, and it's training how to talk, how to speak, how to sound legitimate. And is that training process manipulated during the development? I mean, you're a relatively trustworthy guy, right? I'm going to trust if you're going to make a product, it's going to be good. But what is the degree to which the developers are able to influence how those models are trained and how they interpret all of those words in the way that they provide responses?
Certainly. Yeah, let's kind of break it down into four key concepts when we talk about LLMs. Well, let's go to the data, go into the training process. Kind of at the end of the training process, we can talk about the patterns that have the outcome of that. And then finally, when we interact with the model, the prediction or the inference relative to that. So starting off with data, these language models, they, like you said, the fundamental building block of their interactions is natural language. They came up with the term tokens to separate text. Those tokens, we take them, put them together, and in those vector forms, which we call embeddings. And now those are the inputs that we use to our model to kind of get into the training phase.
So it's understanding how the words connect to each other, but not necessarily what the words mean.
Exactly. So you would see like in that embedding space, sunset and beautiful might be closer together in terms of like distance because they're used together in text more likely, where sunset and butterfly, they might be as far away as possible because they're not used contextually together. And then it kind of gets into like the training itself. So LLMs, especially now, use this concept called neural networks. When I say neural networks, it's actually mapped, that algorithm's mapped on how some scientists were thinking about how the human brain works.
So all sorts of data. It's building a deep neural network, which is a very complex way of understanding the relationship between these different words, these tokens as they're assembled together. At some point, it starts to recognize patterns then, or is the deep neural network the pattern recognition tool?
So it's kind of that training process. As we progress through our data, the model is going to train and learn to predict the next step. Each neuron might learn something unique, but as it progresses through, it will kind of understand and capture the essence of that training data and the essence of what the model developer has incorporated as the reward mechanism.
And you hit a couple of really interesting things there, and I really want to hit on your reward mechanisms. But first, I want to talk about what you said is it predicts what that next word is going to be. So I think the first time that most people have dealt with kind of what the next word is going to be is the classic Microsoft Office or the Google answer, where you start typing and it's got the slightly grayed out letters, tab to complete, and it'll fill it in. Is that operating on the same basic concept?
So at its core, with natural language processing, yes, you could say LLMs have taken the root technology there, scaled it up into almost like that autocomplete on steroids.
And then the other thing that you hit on was the reward mechanisms. Can you dive into that a little bit more for me? Because I think that starts to get into a lot of the way in which we shape, or we being you, the AI developers, are shaping the way that it preferences patterns and provides responses. Can you give me a little bit more of a deep dive on that reward process?
Certainly, yeah. So as these language models, and happens the same with other types of AI models, you have a certain outcome that you're trying to achieve. So for a language model, we might look at the difference between OpenAI and Anthropic's model, ChatGPT versus Claude, for example, and say, hey, Claude has this certain type of feeling. Maybe it acts cheerier or it's more responsive. The developers may have had like a reinforcement mechanism where its responses were trained and were rewarded for be acting in that certain way. These reward mechanisms is us trying to codify through codes, procedures, and algorithms the outcome we want for that model.
So I know that for myself, when I've used large language models, occasionally it will provide two responses, and I'll say, oh, do you prefer this personality or that personality? So when it's talking about a personality, really it's trying to determine which one of the reward mechanisms I prefer as a user. Is that a base level understanding?
So those exactly, those methods is feedback to the developers to then codify, hey, how should we progress with these models? So when you see a model, it's kind of locked into like its pattern matching. So we go through the training process, it has the loss mechanisms and it's set in stone. And it has formed some type of patterns that are encoded into those weights. But to improve the model, developers need to do different types of things. And to go and take the model to these next steps, it needs feedback through interfaces, like asking you which type of response it prefers. So over thousands or millions of users seeing that, hey, we prefer this type of response, the developer can now train in some way, shape, or form a model that performs better to you, the user.
So it's really improving that user interface model as one aspect of it. Does the training and rewards also alter the actual content? So I understand that, and to use the personality concept that you provided earlier, maybe it's going to be nicer. Maybe we're going to get a snarky grok type response. Maybe it's going to be very polite or very formal. But generally speaking, then are we also able to adjust how it provides the response and the different ways in which it weights all of these different tokens that are out there?
Certainly, it will be a mix between if we're seeing that, our model is maybe having sarcastic responses, for example. We could probably address that one of two ways. Is maybe the data itself. We can go back and say, let's remove these sarcastic comments. Another method could be, in our algorithm that's training this model, let's try to capture that in some way, shape, or form in the reward mechanism. Maybe we have like a cheerfulness type of like encoding to give that reward when the algorithm goes and improves itself. So there's different ways to kind of tackle the problem. And I think that's one thing that's really cool in the AI space is these models are consistently improving, and almost in a way, you'll see different companies diverging to kind of hone in on their user base.
So going back when you said that there's four phases, you said data, training, patterns, and inference. So I think we've hit the data and the training and the patterns. Talk to me a little bit about that inference stage.
Exactly. So at inference, the model already has these patterns that are set, and we're just interacting with it through that interface. So we talk about different types of interfaces. It could be you chatting to it, like you mentioned, or sometimes this can even go behind the scenes where we might be pulling documents or pulling news articles and putting that into some type of data set that's used. So the prediction stage, we kind of have everything locked in stone, and we're trying to gather feedback from our users or from our use cases, but use the model as it is until its next iteration.
So you mentioned pulling articles and things. Now, is that the reference of, pulling an article and copying it and say, I want you to consider this in a response? Because that's really getting more into that RAG type interface, isn't it? Where you're able to then feed it information and is that then weighting how it values the patterns? Is it changing the reward mechanisms? Talk to me a little bit about that RAG interface, because I feel like that's what makes a lot of these modern LLMs so powerful.
Certainly, yeah, there's kind of four major methods that you can see that have revolutionized and made these LLMs more functional. System prompts, the chain of thought reasoning method. We'll talk about RAG, that's a very important one. And then even now, tool call, kind of some of the cutting edge research coming out there. So starting with system prompts are kind of like high level overviews of how the system, the AI agent should respond. So you can see this as I want to build a tool that you will interact with that's going to help you with logistics data. So I could say to the AI agent to kind of hone in on its framing, you are a logistics expert that's going to be speaking to commanders that want concise but clear insights on their logistics data. And now the model will take that information, it's weighted differently than your input, and then use that as a core context on how it will respond to you. So it's a very unique way, a very powerful way that even us as users have access to shape our model's performance. That kind of moves into the next phase, which is chain of thought reasoning. So there's been a couple ways that's been addressed. You can action chain of thought reasoning in a system prompt, which is like, hey, think through the steps of this process. Or some of the times it's even built into the model. Well, certain models have been trained to think through the process of how they reason. Think of this like you're doing mental math opposed to writing down your steps. The model, if it's looking at a code, it actually does better if you tell it to show its work. And in some of those models, they don't show you that output, but it's doing it behind the scenes. But, when in doubt, ask the model to think it out. Finally, kind of getting to the point that you had with RAG, super powerful capability for our audience. RAG is retrieval-augmented generation. So it's the thought process that LLMs don't know everything because, like we said, after the training stage, they're locked. So RAG is a way for us to provide large language models context. So an example of this might be, you input that document into your LLM interface. That document's broken up into chunks and it's coordinated in a way that when you ask a question, the LLM's going to see, hey, what in this document makes sense for me to parse through? And it's going to pull that information in, even down to the point where it could reference that document or even that technical manual by line where that information is coming from. Finally, tool access. This is kind of a little more specific. So instead of us providing that augmented generation directly to the LLM, we're giving it the ability to call different tools. This could look like, hey, it has access to an API, essentially just an interface to talk to another website, to pull in, let's say, weather data. Even in the cases of some of the tools people might be seeing on Vantage or other systems, for the large language model to think about what is the query I need to make to get the data from my user. So these are all like very, very powerful things that allow LLMs to almost think about stuff, but know that like in that they don't have like a ground truth of knowledge. They're pulling in ground truths and kind of being different, almost faking their way into like the right answer, but knowing that that's the right answer and trying to put that into their responses.
Yeah, I mean, that's a lot to digest. Let's start with the last point you brought up, which is that tool access. So you mentioned the model then being able to reach out and find information from external sources, going to an API, going to a URL, searching for the weather. The model was trained, it is solidified at that point, as you said, and so it doesn't know what the weather is today. But what it really knows is how to search for the weather. Is that a good understanding kind of at the base level for tool access?
Yeah. So in the system prompt, generally you say, this is how you would use this tool. So if it's like an API, you would say, this is the URL and like the function that it's going to call, essentially the logic and how it's going to do it. And then when you maybe ask the question of what's the weather out in Fort Bragg, North Carolina, it knows how to use that function based off that system prompt. And then that model as its output will call it and like bring that into its context so it can actually answer your question. If you ask the model without that, it might be showing, it doesn't know what day it is. It doesn't know where you are.
No, and that's great because I think that takes it from being something that is stagnant. It's caught in a period of time. That tool access really allows it to maintain the model relevancy without doing a retraining by allowing it to reach out to external resources that are live and updated on a more routine basis. One of the other things you mentioned that we talked about before was RAG. And I know especially within the military, RAG has become very popular because AI models are not typically trained on the regulations and the doctrine that the military uses, that we're all trained on how to use. And so there's a lot of RAG use, especially when we're leveraging some of these civilian models to make sure that it understands what it is that we're looking for so that it's looking at the actual doctrine. Is that a good understanding of how you're employing RAG on a routine basis?
Certainly. Yeah. With RAG, a lot of it's similar to tool where we're just adding context to this model, where without using RAG or another method, you might ask it, hey, some standards from, one of the RTMs. And it might show you something that looks like it came from a TM because it generally knows it's been trained potentially on documents that look like that.
So when we're dealing with RAG, you're influencing the model. And I've seen people use a RAG interface. They'll upload FM1-02 is everybody's favorite, right? I want it to provide me a unit icon for this type of organization. And it routinely gets it wrong. And it'll ask for an infantry unit and I'll get a cavalry unit. It seems like we can use, and I've heard it called scratchboarding, we can use the user prompts to go in and give that model some pretty direct guidance on how we want it to use those RAG documents. Is that an effective means? And am I having a good understanding of how those tools relate to one another?
I think you bring up a point where, us as humans, we're kind of interacting with this black box interface where we didn't develop it. So doing things like asking LLMs or even using LLMs to help plan how you would use them is a great method because it helps us in our own terms try to explain to that model how to use things like RAG in a way that would be beneficial to us. And with one final point, when we talk about RAG and how it works at a fundamental level, it's oriented towards text. So when we're talking about getting these LLMs to understand icons and different aspects like that, it kind of is almost a paradigm and a framework that is hard for them to see. And they struggle with most visual tasks for that reason.
So they're going to have the same sort of problem on understanding a graph or a chart that they would have on understanding a unit icon. So it's able to see something. It's able to tokenize that information in some way, but it's not right. And that can become an issue as well when you either get answers that are either slightly incorrect, which has a risk of one type, completely made up and nonsensical, which is a whole other category, and everything in between as far as the inaccuracies. Can you talk about how AI and why AI makes some of those different types of mistakes?
Yeah, certainly. When we talk about AI and mistakes, this is kind of like a whole frame of thought as people have tried to make these models better. And one of the cores, kind of going back to one of our early topics about AI's reasoning, it's understanding and kind of forming a chain of thought based off of how people have talked. So it doesn't really have a sense of the real world. It has a sense of how you've talked about the real world. So if you're saying, apple fell from the tree, it's going to look at, hey, what are other learnings that I know from text about apples falling from the tree? It's like, oh, falls on the ground and goes splat, opposed to, oh, gravity caused the apple to fall from the tree. It's the way it's understanding the world is biased through human text and how humans interact. Hallucinations, another one that very, very big, where AI sounds confident in all of its responses, whether or not it's true. So we go and we say, AI is predicting how text is. So it's going to give you something like you would have said. You could even say AI is like the greatest method actor in the world. But in the cases where it doesn't know what it's going to do, it's a method actor. So it's going to act it out. And it's going to give you an answer, even if it doesn't know if it's right or wrong.
Yeah, and I have certainly experienced those answers. The big two categories that I've come up with are it's incorrect because there is a disagreement from different resources of what true is. But I think that the more interesting one are those fabricated answers that are just created, hallucinated, method acted, whatever we want to call it, where I ask it to provide something and it makes something up. Personally, using that chain of thought reasoning, using that scratchboarding process, I've kind of discovered that the more that I press it to provide me a certain answer, the more likely it is to do that. The AI is programmed to give me what I want, even if what I want is wrong. Is that a good way of understanding that?
Exactly. Where you can talk about these reward mechanisms. AI is, and the method is called reward hacking or specification gaming, where us as developers, we've had these different algorithms to try to make it more helpful. And if my AI is trained to be more helpful, it wants to give you a response. So in those cases, it might bypass other logic or other avenues of training or learning, because it knows that its core principle is to be a helpful, happy, wonderful AI agent at no matter the cost. AI agents at a core will respond to you as they've learned how, no matter if it's right or wrong. That's why we have to use methods like tool access, RAG, chain of thought, and system prompts to try to scope these models into a framework to be more reliable, and especially in the military context.
Just because it's out there on the internet, just because it was trained on it, doesn't mean that it's true. So there's a user responsibility, not just to use the prompt in an informed manner, but also to trust but verify, to go through and check the responses, check those sources. Are there good methods and processes and TTPs to make it easier to go back and check those responses and validate them individually?
Yeah, I think part of it rolls into how you use AI, especially those LLMs. So in my work, doing a lot of programming, I can send program or instructions to an LLM, receive it back, and then check it using tests or even making sure the code runs. So I am not trusting that AI output inherently. I have mechanisms in place to ensure that that output is valid, it's doing what I want it to do, and it's not going to break something. You don't really know what's going on, or potentially what's happening behind the scenes. If a hallucination exists, potentially there's some reward hacking or some bias in the training data that's going to get you an inaccurate response. I'd recommend doing things like, if you're going to have an AI check your paper, for example, or your memo, have it just provide its recommendations, and you go and take that output and manually check it, opposed to accepting an entire rewritten paper, because in the case it could have hallucinated in an area that you weren't even focused on and provided you a completely different paper as a result.
I think one of the other everyday interactions that people have with AI is in a lot of the GPS and the mapping space, and it's prevalent everywhere. And I feel like that's something I've been seeing more and more is AI enabled. Can you tell me a little bit about that process?
We have other types of models that exist in spaces like that GPS. So looking at all the different patterns of roads, how users are traveling, speed limits, other type of information, they could optimize your route and get you to that location faster. Flipping the coin too, you could even bring it back to the tech space where, hey, you had your email and you're getting various spams, and you can train KI and machine learning algorithms to detect, is this spam or not, and pre-filter that out into your spam folder or any other folder for that matter. Me working in logistics, the predictive maintenance space, where we might have sensors or different aspects of kind of data collection on tanks or helicopters. And we can predict a failure because we have data on all the other vehicles of that model and when other failures happened and can label it. And then even going into other spaces in the military context, image recognition, knowing what's in an image for intel analysts, detecting, is this a Russian T-90 tank, or is this some other type of enemy asset, a C2 node? AI exists in a lot of different paradigms outside of just the large language models that kind of made it viral in the chat interfaces. But one thing about when you say the interface, a chat interface, you can ask any question or answer to it. And, it has a lot of ability, a lot of capabilities. But it also, if it's asked a question not in its purview, might also be more prone to hallucination. Whereas some of these other types of interfaces, right, I could have the same prediction shown in a user interface, some type of dashboard. The user is kind of constrained in a different way. So we see kind of a divergence where some users and some companies are very chat heavy forward, but are generally okay with some hallucinations or some error, some gap of error. Whereas the dashboard, once somebody kind of gets ingrained or has good design, they do get the same response or even a more concise response. But there's a curve to get it.
But again, we've got to ask it questions that are related to its area of training expertise. If I've got a model that's being used for maintenance and I ask it to predict the weather, or I didn't use computer vision to identify an enemy tank, it's probably going to fail at that. In best case, it fails in a very noticeable way. Worst case is that it fails in a way that is a very convincing hallucination, but is still wrong.
Exactly. So that's where people like me and other people at AI2C and other labs and research centers, we try to make these models or make these interfaces. Sometimes it's adjusting models themselves. Sometimes it's system prompts. Sometimes it's even choosing which model we'll use so that when you interact with our models, that's going to give you a reliable answer. And then kind of bringing it even back full circle. You said, you have those two responses and like, which one would you rather have? Us as developers then hopefully seeing how you used our model and how our model performed to iteratively make it better to have a better AI enabled future.
So there's an ethical development that's happening, at least within the Army and hopefully within all organizations, to make sure that we're developing the models that are going to answer the questions as effectively as possible, as accurately as possible, to fail predictably in ways that are safer. But there's also a responsibility for users to use these responsibly and to understand what these tools are for. We don't use screwdrivers to hammer in nails. And so we need to make sure that we understand that these tools in some cases are very broad, but in many cases are tailored towards specific functions. And they're not going to necessarily perform as we want if we use them outside that narrow band. Is that correct?
Exactly. So you could go and look at the difference between maybe general queries on GenAI.mil opposed to somebody building a custom agent studio in a platform like Army Vantage, where GenAI.mil, wonderful cutting edge model, but if you asked it to go and do research on logistics data, unless you gave it those capabilities, which you can, it's going to fail, and hopefully in a graceful way. But if you go to that agent studio where maybe some developer, some ORSA, or even just somebody who's really high speed and wants to learn AI has tuned and given a model different tools, it's going to be able to perform better than even if it's a smaller model, because it's been given access to the right tools and procedures to answer your question. So it's a lot on both us as developers, as users, and then as the community to kind of steer these tools in ways that make the Army better and in an ethical way.
No, and I think it keeps coming back, to those 4 points that you brought up: the system prompt, the chain of thought reasoning, the RAG, and having that good tool access all combined in a variety of ways to impact how those tools are used, how they're most effective, and how they can be employed most efficiently. We've covered a lot of ground today. Is there anything that you really want to close with before we wrap up today?
Yes, I think AI is a really awesome technology, but I think all of our listeners should understand that even though this technology is very, very powerful, it has some limitations. So when you go and use models, whether they're through chat interfaces like large language models, or even if you're using parts prediction, kind of in the domain that I'm in, you have to understand all models will fail, but some models are useful. So take a level of skepticism to your functionality of these models and use them in ways and try to encourage your developers to develop them in ways to allow them to fail gracefully and for your organization to handle those failures in a graceful way as well.
I think that's a great takeaway. It's not that different from what we've done in staff work for years. All staff estimates are wrong. All of them are useful. So it's another way of incorporating a digital staff estimate into the planning process that's able to access a lot more data and is able to be tailored and refined over time. It just gets better faster than the humans are normally able to keep up with. Thank you very much for being here today. We've covered a lot of great material on how these LLMs are trained, how they recognize patterns, the reward structures that are used by the developers to improve those, as well as what I think are a lot of great takeaways for leaders and users to understand and how they can employ these large language models more effectively. I want to thank you again for coming today. Had a wonderful conversation, and I hope to talk to you about this again soon.
Yeah. Thanks, sir. Thanks for having me.
I hope you'll join us next time for episode 3, Why AI Matters to the Army Now, where we're going to talk about the speed and decision advantage that AI is able to provide and the ways that it is able to reduce the human workload while simultaneously enhancing training, simulation, maintenance, logistics, and planning applications. We'll see you then.